Let us start. First question. The unit cell with crystallographic dimensions A is not B, B is not equal to C, alpha is equal to gamma is equal to 90 and beta is not equal to 90 degree. We have to tell which of the unit cell is going to be formed by using these crystallographic dimension. By given this data, you have to check which the unit cell is going to be formed in this case. Let us see the options for it: triclinic, monoclinic, orthorhombic and a tetragonal. These are the four options we have given. As you know that we are having 7 crystal systems. Those were known as, those to be known as cubic, tetragonal, orthorhombic, monoclinic, rhombohedral, hexagonal and a triclinic. These are the 7 crystal systems were present in our solid systems. Okay, how to remember these things? That's why I have given you a mnemonic to remember these 7 crystal systems. Let's see what is the mnemonic there. Class test on Monday. Ride hard together. Here class stands for C, test stands for T, on stands for O, Monday stands for M, ride stands for R, hard stands for H, together stands for triclinic. Like this is going to be formed, right? By using the crystal system, as you can see here, cubic is A is equal to B is equal to C, where the others should be known as alpha is equal to beta is equal to gamma is equal to 90 degree. The second way is going to be tetragonal. A is equal to B, where B is not equal to C. Alpha is equal to beta is equal to gamma and is equal to 90 degree. In the case of orthorhombic, A is not equal to B and B is also not equal to C. Next, the interfacial angles is going to be alpha is equal to beta is equal to gamma, that is going to be 90 degree. What about the monoclinic? A is not equal to B, B is also not equal to C. As you can see here, the interfacial angles, alpha is equal to gamma is equal to 90 degree, where beta is not equal to 90 degree. Rhombohedral, A is equal to B is equal to C and alpha is equal to beta is equal to gamma, where gamma is not equal to 90 degree. In the case of the next one, hexagonal, A is equal to B, B is not equal to C, alpha is equal to beta, beta is equal to 90 degree. The third angle, that is interfacial angle, gamma is equal to 120 degree. In the case of the triclinic, A is not equal to B and B is also not equal to C. The angles are alpha is not equal to B and beta is also not equal to gamma, where gamma is also not equal to the 90 degree. Let's see the options again and see what the condition is going to be satisfied in this case. As you can see here, A is not equal to B and B is also not equal to C, where the angles are alpha is equal to gamma is equal to 90 and beta is not equal to 90 degree. As you can see that which example is going to be satisfy this case. It's going to satisfy that is to be known as monoclinic is the correct answer in this case. Monoclinic, where monoclinic is A is not equal to B, B is not equal to C, alpha is equal to gamma is equal to 90 degree and beta is not equal to 90 degree, as you can see here, right? That's why the answer is going to be for this question is going to be option number 2, that is monoclinic. So let us jump into the second question. While charging the lead storage battery, lead storage battery. What are the options were given? Number 1, lead sulfate, PbSO4, lead sulfate on anode is reduced to lead. Okay. Option second, lead sulfate on cathode is reduced to lead. Only the electrode position have been changed here in the option A and option second. The lead sulfate on cathode is oxidized to lead. This is your option 3. Fourth option is going to be lead sulfate on anode is oxidized to lead oxide. As we know that lead storage battery is an secondary cell type of a one. Okay. Lead storage battery is a secondary cell. You know the definition, basic definition. These cells can be recharged and can be used again and again. Initially, the lead storage battery going to be having of anode as a spongy lead. What do you mean by spongy lead here? Means a pure type of lead is going to be used. It is in the anode side. The cathode is going to place with the lead oxide, that is PbO2. You have to remember that which electrolyte have been used in the case of the lead storage battery. In this case, we are using the electrolyte that is 38% of sulfuric acid by mass. As you can see, the diagram here has given as the spongy iron on the left side, lead oxide in the right hand side. Some electricity have been placed here, and there is an electrolyte have been placed here. So let's see what is the discharging reaction, how the discharging reaction takes place. In the anode, the lead and sulfate going to react to form lead sulfate and lose their 2 electrons. Here the oxidation is going to be happening in this case. Okay. At the cathode side, lead oxide and sulfate is going to react with an acid and going to gain some electrons to become lead sulfate, and water is going to be formed. As you see, the net reaction is going to be Pb plus PbO2 plus 2H2SO4 gives rise to 2PbSO4 plus 2H2O. In this reaction, the catch point is going to be in the during discharge reaction, you are going to consuming the sulfuric acid. You are going to consuming the sulfuric acid in the case of the during discharging. What about the charging case? In the case of the charging reaction, when the battery is going to charge, the lead anode place, the lead sulfate is going to gain some electrons. It is not going to lose. In the case of the discharging, is going to lose its electron. That's oxidation. Is going to be reduced. The anode is going to be reduced to become lead, and cathode PbSO4 plus 2H2O gives rise to PbO2 plus SO4 minus 2 plus 4H plus 2 electrons. Here the acid is going to be released in the case of the charging case. The overall reaction is going to be 2 PbSO4 plus 2H2O gives rise to lead plus lead oxide and sulfuric acid. See, the answer is going to be during which action is going to be. He is asking the while charging the lead storage battery. You have to see for the charging. Okay, by casing you can see that the lead sulfate is going to be reduced. Where in the which position? In the anode. In the anode, the lead sulfate is going to be reduced to form the lead. Is there any option is there? Lead sulfate is an anode. It is reduced to lead. The answer is going to be for question number 2, that is going to be option 1. So let us go into the third question. Adenosine is an example of adenosine. Example for option 1 nucleotide, second one purine base, option 3 pyrimidine base, option 4 nucleoside. As we know all that adenosine is one of the 4 nucleoside, that building blocks of the RNA. As you know that to build an RNA we require 4 nucleoside. Those were the AUGC. AUGC means what here? These are the nucleosides which are required to form the the 4 elements. This one could be required. That is to be RNA. RNA means ribose nucleic acid. What do you mean by AUGC? adenine, uracil, guanine and cytosine. And you know that, I think you already know what are the nucleosides were present in the DNA. Yes, yes, the answer is going to be ATGC. Here, what do you mean by ATGC here? A stands for adenine, T stands for thymidine, G stands for guanine, C stands for cytosine. So let us see the what are the basic properties. What do you mean by nucleoside? Nucleoside is made up of nucleobase and a sugar. That is going to be pentose sugar is going to be required to form the nucleoside. And a nucleotide is there is a combination of nucleoside and a phosphate sugar. Is going to be required a phosphate. Okay. Let's see the what do you mean by purines. Purine, these are the base. In this case, in the structure of that, they are going to having the 5 or 6 membered ring going to be having present here. There is going to be a heterocyclic compound which is going to be present of a nitrogen in the both the cases. In the case of the purine bases and also in the pyrimidine base. What do you mean by here? A means here adenine, G stands for guanine, H stands for hypoxanthine, X stands for xanthine. These are the 4 purine bases. These were having the 5 or 6 membered rings having the heterocyclic compound that is to be known as nitrogen. In the case of the pyrimidine, uracil, thymidine, cytosine, and the fourth one is going to be orotic acid. Orotic acid, these are the 4 pyrimidine bases were present. These having the characteristic property they are having only 6 membered ring with the nitrogen as a heterocyclic compound or molecule. The answer is going to be, which one is the answer? The adenosine is an example for the nucleoside. Okay, let's go for the fourth question. Orlone is one of the polymer type. Let's see, Orlone has a monomeric unit. As you have already studied that, there is going to be 2 terms which are going to be very famous. It's going to be polymer. Second is to be known as monomer. By the repetition of the monomer, going to form the polymer. Here mono means one, poly means many. Many repeating monomeric units going to be formed as a polymer. In this case, he is asking in the polymer Orlone, which monomer is going to be having here. Let's see the option here. First one is going to be acrolein, option 2 glycol, option 3 vinyl cyanide, option 4 isoprene. Okay, let's see the answer for this. Okay, acrylonitrile, vinyl cyanide, these are one of the same monomeric unit. These are the acrylonitrile and vinyl cyanide. These are the 2 monomeric units and having the structure CH2 double bond CH single bond nitrogen. Here N represents means polymer. Here's many number of repeating here. That's why answer is going to be acrylonitrile or vinyl cyanide. In upcoming they may ask the what is the polymer name which are going to form the vinyl cyanide or acrylonitrile. Okay. In addition to that, there are more polymers which are going to be formed. That should be known as pan polymer and Buna N polymer. These are also one of the important polymers. Okay. If you are having interest, let's see the second, the third, the first option. What are the rest of the option? How would they going to be? Decide answer. Acrolein. Okay, the first option. IUPAC name of this will be known as 2-propanol. 2-propanol. AL stands for the aldehydic group. It's going to be aldehydic group. Definitely there is a presence of aldehydic group here. CH2 double bond CH CHO derived from acrylic acid. Okay. Glycol or ethylene glycol is a subunit of glyptal. Yes, you already know that. Along with the phthalic acid. Okay, along with the phthalic acid glyptal. There is very important to manufacture the glyptal and the phthalic acid. There is going to be required for preparation of the glycol or ethylene glycol. This is the polymer here, and these are the 2 monomers. Okay, next going to be isoprene. Okay, isoprene or the IUPAC of this compound is going to be 2-methyl 1,3 butadiene. Okay, this is a monomer of Buna N and a natural rubber. Okay, isoprene. Okay, butadiene, that should be known as 2-methyl 1,3 butadiene is the monomer of Buna N and a natural, which is also going to present in the acrylonitrile also. Okay, it's going to be monomer. The answer going to be here vinyl cyanide or acrylonitrile, the other name of this compound. Okay, let's go with the fifth question. The two electrons have the following sets of quantum numbers: p is equals to 3, 2, minus 2, plus half. Here and q is equal to 3, 0, 0, plus half. Which of the following statement is true? Let's see the four statements. Number 1, p and q have same energy. P and q have the same energy. Next, option B, P has greater energy than Q. Option 3, P has lesser energy than Q. Next, fourth one, P and Q represent the same electron energy or same electron. What do you mean by P and Q? These are the two sets of quantum numbers. Here's the P and Q means here. These are the two sets of quantum number. There is some significance about this one here. Here, P is equal to 3, 2, minus 2 and plus half is there. What is the significance of this? What this represents? 3 represents the principal quantum number. Here n is 3 here means to be n. That's n means principal quantum number. And the second part, the 2 represents the L. L means here azimuthal quantum number. And minus 2 represent here m. M is here magnetic quantum number. Plus half. Plus half represent the spin quantum number. As you know, already studied that according to the above principle, there are Hooke's rule, above principle. There are many types of rules that are going to be present in the while discussing the quantum number. Okay, especially the atomic structure chapter in the class 11. It tells that minimum energy is going to be filled first, then next shell must be filled according to their higher energy. This going to be comprise the main rule. This is to be known as N plus L rule. What do you mean here? Yes, definitely you know that N means here principal quantum number and small l represent the azimuthal quantum number. If we are going to see the values of P and Q, just we have to be add the principal quantum number and the azimuthal quantum number. If you are going to getting the more values of P, and that's going to be which is going to have more values, that is to be considered as is going to having the more energy. Okay, by observing the p value, by p values, n is equal to 3 here. Yes, n is equal to 3 here, n is equal to 3 here, and l is equal to 2 here. I'm just adding it by using the n plus l rule. That is 3 plus 2 is going to be as 5. Okay, if you are observing the q values, if you go to observing the q values is equal to q is equal to 3, 0, 0 plus half. By using the q values, I'm getting n is equal to 3 here. Yes, n is equal to 3 here, and l is equal to 0 here. Okay, this is the significance of this. You have to remember by solving these questions. Okay, q is the answer. The total sum of this is going to be, I'm getting as a 3. I know that. Starting, I have to fill up with the first one 3. I have to fill up this one. Then I have to go with the 5 value. Okay. By observing the 3 is going to be lesser than the 5, means 5 is greater than the 3. That's why P has greater energy than Q value. Why? Because the value of N plus L is greater. Okay, where is the option here? Yes, exactly. Option second is the right answer. P has greater energy than the Q.